Hello, everybody. When I say IP, you say six. IP. IP. Not bad. Okay, good stuff. Hello, Sean. This is AWS, IPv6, and pain. So, if you've ever been anywhere near so much as a network device in the last 40 years, in fact, you've all done this. You've all had, at least once in your life, access to a device which has had one of these assigned to it. An IPv4 address. And most of you may know, whenever you access a computer somewhere on the internet, by typing its domain, it ultimately maps to one of these. This is home on most of your home routers. And some of these will be familiar to you. Oh, there's a delay. Good. Google, BBC, that's not good. And Wikipedia. This isn't being taken from my time, is it? Yay. Good times. You get it. They're everywhere. In fact, they are one of the most foundational pieces of the modern internet, and thus one of the most important technical decisions made in the history of humanity and how we reach one another and their information in different places. But we have a problem, and it's this. Can anybody tell me the significance of this number?
How many IPv4 addresses there are?
Exactly right, 100 points. That is the maximum possible numbers of IPv4 addresses. And why is that the maximum, you may well ask? Well, it's because each of these numbers, separated by dots, is representing an 8-bit number. And when you have a range of 0 to 255, you've got 256 possible numbers in that set. Simple stuff. 4 lots of those is 32 bits, and the largest signed integer you can have in 32 bits is 4,294,000,000. Yeah, that's right. 967,296. If I struggle with that, you're going to see what's going to happen in a minute. Good Lord. Now, who can point out the problem with this number?
Not very many.
Exactly right. 100 points. Contest. Good stuff. It's actually really small. All right. Now, back in the 80s, when there were a couple of hundred devices on this thing called the ARPANET, this number will have seemed huge. But with the rise of what we call the internet, you may have heard of it, which, if you give it a quick Google, has about 10 billion devices on it at current. Right. Now, don't know if there are any mathematicians in the room. 10 billion is bigger than that. All right. So there just aren't enough IPv4 addresses to go around. And there's a whole host of clever ways that you can make one IP address be useful for multiple devices. But the fact of the matter is, eventually we're going to run out. Right? When? Hard to say. Not tomorrow. Right? Probably not next year. 10 years from now, we're going to have issues. All right? So collectively, me and all the other internet users have gotten together, and we're just going to switch it off. The internet was an interesting idea, lots of up and downs. Was it a force for good? Jury's still out on that one, but it was a fun experiment. Back to sending postcards, reading newspapers, and listening to cassette tapes. And yes, that is my mother. I joke. The problem is we don't have enough IPv4 addresses, right? So surely the solution is, let's just make more of them. And this was the prevailing thought in 1995. Let me take you back to 1995. Brad Pitt had just been named the sexiest man alive by People Weekly. Braveheart was the blockbuster film of the year. Seinfeld was the most watched television show in the world. And a small website called Amazon.com sold its first book. Can't imagine I got very far with that. But in amongst all that came a new IP protocol, IP version 6. An IP version 6 address looks a bit like this. Now, it's not as human-friendly as 4 numbers, but it's not for us. It's hexadecimal. It's for computers to find one another. And it solves the problem of IPv4 exhaustion. But in that range, the total number of possible IPv6 addresses is big. More specifically, it's 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, we're halfway there, 374 quadrillion, 607 trillion, 431 billion, 768 million, 211,456. Or 2 to the power of 128. Fun fact, that is a big enough space for numbers that if every grain of sand on Earth had an IPv6 address assigned to it, you'd have enough to assign billions to each sign of each each grain of sand on the planet. And that starts to bring with it a whole host of benefits just beyond the sheer volume of it. But let's focus on that a little bit. Well, I've got a duplicate slide there. Yes, as you will have gathered, there's lots of them. And what's nice about that is we don't have to ration or limit how we use them. We can generate a random IPv6 address for pretty much anything we're ever going to use. And because there's so many of them, very little opportunity for collisions, we can consider an IPv6 address assigned to a thing as permanent. Right? You don't need to reassign, you don't need to reuse, you can just keep it that way forever. And that's pretty handy for computers to find things and knowing where they are on the network. You can also, because of the volume of addresses, essentially bin NAT. You don't have as much of a, those of you who have suffered the NAT gateway will be very pleased to hear this, But it can essentially allow end-to-end connectivity because you know where these things are on the network. Makes it a lot simpler. There's a whole bunch of stuff that comes with that as well. But essentially, it brings the internet a bit more back to its original guise as a peer-to-peer network, rather than a whole bunch of walled islands. And it's cheap. You see, capitalism, we're in that part of the conversation now, capitalism demands that there will be, if there is a supply, and that supply is limited, then the price of that supply goes up. And IPv4 is still immensely popular, but it has a finite supply. A bit like gold or COD. I'm going to miss COD when it's gone. But if you want to buy a block of IPv4 addresses to insulate yourself against exhaustion, then they're hella expensive. Thousands and thousands of dollars. If you owned a block of those in the 90s, as you could have done, you could get a mortgage on that sort of thing. It's a really large amount of money. But IPv4, IPv6 is functionally infinite and thus worthless because the supply will never be able to outpace the demand. Right? You're never going to need several quintillion IPv6 addresses. If you do, God help your AWS bill. And because it's worthless, no one's going to pay for it. Someone's always going to offer it for cheaper. So, good times. So let's do it. IPv6 is a no-brainer, is it not? It's cheap, it's secure, it's been around for 30 years. It should be super simple to get going with it, right? Well, I thought so too, because I was an idiot. But oh, my sweet children, if that were the case, I would not be here tonight. I would be at home doing something productive, like watching whatever inane crap that's on Disney Plus these days. Instead, I come here with a story of woe, of dreams that were dreamed and lost, of hair that was pulled out, and many an evening consulting with an idiot in a box trying to figure out what I was doing. ChatGPT, if you're wondering who the idiot in the box is. Let me take you back to New Year's Eve 2024. Yes, it's a story, it's a narrative piece, right? I was in my hometown, which is Luton, cue applause, watching the fireworks go off as the clock struck midnight for a new year. And it occurred to me, it had been 4 years since I'd shipped anything. See, I'm in developer relations. The curse and the blessing of DevRel is I spend a lot of my time helping other people ship things, but I don't get to ship many things that aren't community programs or CLI tools. I write code every day, some of it even quite good. But the thing that, giving people a thing that they can get their hands on and have a benefit from, it's been a while. And so, on a cold hillside in the middle of the Chilterns, at an ungodly, but frankly, heartwarming amount of fireworks, they really put on a show this year, I made a rare thing. I made a New Year's resolution, and I was going to keep it. I was going to make something this year, and I was going to ship it, and it was going to be something that I could be proud of. But what to make? That's the big question. We've all got side projects that have gone nowhere. I have 248 GitHub repos. 150 of those are private and have never been finished. And they never will. They will outlast me, but they will never be finished. Well, I've been a developer advocate for one cloud company or another for the last 7 years. I've celebrated their successes, I've worked to lessen their losses, and I've raged against some absolute shit shows, frankly. But that's a talk for another day. So with all that knowledge, all that joy, all that experience of suffering, I decided I'm going to make a cloud platform. Specifically, dream small, that's what I always say. My own cloud platform, specifically a PaaS, one where things were done just the right way. Something I could stand behind proudly and say, I built this, I think it's great. So what do you need to build a cloud platform? Computers. It's not a trick question, But the cloud is just someone else's computer. And in this case, there would be my computers, beautifully set up to make whatever you want to make happen. And ship and fun, and it's going to be great. But where do you get computers from? Where's the dealer? It's not PC world anymore. We've moved on. This is not the 90s anymore, regrettably, because those were good times, right? You need a cloud platform. And given that I've worked with AWS in one form or another for the last 9 years, and not too long ago I was a senior developer advocate for AWS in the UK and Ireland, I went straight to AWS. Oh, that's a bad contrast. I went to AWS. And yes, it's turtles all the way down. Wheels upon wheels, layers upon layers. But if you want to create, configure, and destroy computers as quickly as you need them, this is where you go. And AWS, as we've seen in Martin's wonderful talk, comes with a whole bunch of services that make spinning up and creating, orchestrating things really, really easy, really, really powerful. You've got the CDK for defining instances and processes. You've got DynamoDB for storing user and instance data. Lambda for the odd job that you need to get done every now and then. It's a one-stop shop. It's great. But while I spent most of January hacking away my MVP, I realized that AWS was going to release a charge for using IPv4 addresses because, again, supply and demand. No biggie, thought I. It's $1.50 for an IPv4 address, right? Not a huge amount of cash. But then I realized it's a bit of a pain. One of the things I wanted my cloud platform to be was cheap. Something that's been driving me nuts in recent years is everything as a service. You want a database? That's a service, and it's $5. You know, need something to process your logs? That's a service, and it's $5. You know, want to run a small static website? That's a service, and it's $5. It's just endless amounts of small bits of cash. I spend hundreds of dollars each year building nothing. It's maddening, right? And it starts to make running really small things that are quite simple quite expensive, you know? And, you know, I'm old enough to remember and have used LAMP stacks. You know, remember those? Linux, Apache, MySQL, and PHP? But they're all in one computer. Right? And for that stack's failings, numerous and vast, it was still incredibly capable of handling a decent amount of traffic for a decent amount of users. And it was all on one computer. And it was $5. And I missed that. And I wanted to bring that back on my platform a little bit. You know, no adding resources to pay for additional functionalities. I wanted one resource that you could add functionality to it. Squeeze the usage out of those instances, right? Bill Gates once said, 640K is more memory than you'll ever need. So not for most people, right? 512 megabytes is what I deem to be, you know, about all right for a small but capable web service, especially something like a LAMP stack with a node application and a database. And so I went for the T4G Nano, Amazon's cheapest, smallest instance in EC2 in EU West 2. It's about $3.50, but this is where the 150 starts to hurt. So this is 343 pence. No, this is $3.43 per month, right? And with the 150, it's $4.93 per month, per instance, right? I want to start charging people at like $5. I want to start charging for $5. So my profit margin goes from about $2 to 7 cents. Hardly worth the time, you know? Either I get as big as Amazon and spend millions of dollars with them so that I can pay my rents, or I just don't use them. And, you know, you can play with spot instances and you can play with reserved, like reserved capacity. But, you know, now I've got to either build a system where I can't trust or have capacity to keep up with any potential customers, or pay up front for a bunch of servers that I may not need ahead of time. And one of the key tenets of cloud computing is you pay less up front, right? So that's not viable. So this $1.50, it's small, but it makes my thing impractical, which isn't great. So that's pain point one. And in fairness to AWS, it's intentional. If you want to change someone's behavior, you need to motivate people to change, right? Everything's working right now. It's not costing anybody anything. But if this charge, you know, for me, it's a pain in the ass. For a conglomerate with thousands and thousands of instances, that starts to hurt your bottom line, that $1.50 charge, right? So you're motivating people to do the right thing. It's to move to IPv6. Good signs. But I'm at the start of my journey. And, you know, I don't have a huge amount of resources or infrastructure that I need to provision at any one point. And because I'm doing everything the right way, I've been a good boy, all this infrastructure is defined in code, right? No fighting about with the AWS console. Leave it alone. It's like heroin. It's bad for you, even though you love it, okay? But it should be trivial because everything's in IAC to move over my EC2 instance to an IPv6 address, right? But my sweet children, if that were the case, I would not be here tonight. I would be at home doing something productive like conditioning my hair or stroking my beard. Instead, I come here with a story of woe. And this time, it's about the CDK. Now, the CDK is a fantastic piece of kit. Don't get me wrong, right? Take your favorite language, write what you'd like your AWS stack to look like, and then have that code spit out a CloudFormation template, and voila! You have a software-defined infrastructure doing exactly what you wanted to do, or what you told it to do, because what you wanted to do might not match up with the code you wrote, but that's on you, not AWS. So adjusting my CDK to utilize IPv6 should be a fairly straightforward process, right? AWS has known they're going to make this change for a while. It's a big thing. They gave people lots of heads up, so no surprises. So they've lined up the ducks and gone everything ready for a swift switch over, right? No. Back in January, when I was working on this, The docs for IPv6 were woefully outdated. There'd been some pieces like early last year, and they largely documented the kind of happy path, which was the dual stack, IPv4 and IPv6 in your EC2 instances, but not just IPv6. And that's the last thing I need. I don't want IPv4 anymore. I want IPv6 because I don't want to pay for it. I'm trying to be a good boy, right? I don't want to just pin IPv6 on top. And auto-assigning an IPv4 address in the CDK is super simple. So naturally IPv6 would be simple as well, right? No, it's undocumented. I had to reverse engineer the CDK software to figure out what the undocumented flags were that would enable me to auto-assign an IPv6 address from a whole array of them to the thing. Like, it was not fun. That was not fun. It was pain, right? We're starting to see the focus of the talk here. And bad form on Amazon's part. If you're going to charge for something that's going to cost people money, at a minimum, you should document how to avoid that thing you don't want them doing in the first place. Not just like, hope it'll be fine and hope people read GitHub issues. Not leave it to whispers in GitHub and Twitter. There was a lot of whispers on GitHub and Twitter for people to find this out. But I figured it out, right? I got it done. And plain sailing from here on out. Sure, it took a week of my life. Not bitter about that at all. Hundreds of EC2 deployments and reverse engineering the SDK, but I got there. We're good to go, right? I have an IPv6 address. It's attached to my instance. Should just be able to connect to it over the internet, right? But oh, my sweet children, if that were the case, I would not be here tonight. I would be at home doing something productive like bleeding my radiators. Instead, I come here with a story of woe. And this time, it's about IPv6 and ISPs. You see, once I got my EC2 instances all set up with their public IPv6 addresses, I spun up a HTTP server and tried to connect with just the IP in a browser. And I got nothing. Literally nothing. Weird, but maybe I hadn't cracked this thing quite yet. So I did what you do normally. I opened the Network Inspector tab. I tried to ping it, got nothing. Tried to access it on my phone, nothing worked. Misconfigured server, surely. But I was fairly certain I'd nailed this. So out of a touch of curiosity, but also largely desperation, I opened up the Tor browser on my system. Who has the Tor browser here? Yeah, it's a good piece of kit. Check it out. Now, the Tor browser is a super handy tool if you want to be absolutely certain there's not something screwy going on with your local system, because it proxies all your requests through at minimum 3 other computers. Right? So there's something going on your network, it encapsulates it, routes it through down your network, and you can be sure that if you can access it, all is good. It's you the problem, not the network, right? And it worked. The server was live. It had an IPv6 address. It was accessible, just not to me on my devices. So why could my laptop not access it? Why could my phone not access it? Because this is Britain, okay? Most every major ISP in the UK does not offer IPv6 supports on their network. What does this mean? Well, it means that if your server is only accessible over IPv6, you're shit out of luck. There's no way around that, right? Here's a graph. Because in the UK, only 50% at best, sometimes, do the ISP support IPv6. And worldwide, it's 60%, right? So that's at least half of your audience that can never, in any way, on their internet connection, get access to your site. So now what? That's, what do I do? My server is enabled, but the internet isn't ready for the thing that they want to happen. But that's not AWS's fault. That's our rubbish ISPs. Okay, that's on them. That's not on Amazon. But I guess at this point, I'm condemned to a dual stack. No, because a hero enters the fray. It's Cloudflare. Okay. Now they've got this neat feature which enables you to deploy a proxy to a quadruple A record, which is an IPv6 DNS record, like the A record for the IPv4, which will allow you to route traffic through their CDN with an IPv4 access point through to your IPv6 enabled instances. So instead of delivering traffic directly to my instances, it goes through the CDN network that Cloudflare provides. And you get a whole bunch of other stuff there too for free, which is great. I've done it. I have an IPv6 only stack. It can be accessed via IPv4, but I don't have to pay for it. Good times. That's that. Thank you for your time. Nah, I'm joking, there's so much more. You would think that having my server accessible through a CDN reverse proxy over IPv4 and 6 would be the end of the story. My cloud's on the internet, people can start building things. But oh, my sweet children, if that were the case, I would not be here tonight. I would be at home doing something productive, like making sure all the cabinets in my kitchen close just the right way. Instead, I come here with a story of woe. And this time, it's about the state of AWS support for IPv4 on their own services, which is why this talk is called AWS, IPv6, and Pain, right? You see, once I had everything set up, I thought I was good to go. My EC2 instances, when they booted, would temporarily be granted permissions to hit a Lambda function to report their public IP, so the Lambda function would go to Cloudflare, write the DNS record, and then you have this automatically mapped server on the internet. Great, wonderful. But I noticed that my Lambda function wasn't getting invoked anymore. I thought, that's odd. I haven't changed that bit of code in weeks, because it's been weeks at this point. But maybe I tweaked something in the CDK when I was tearing through it, trying to figure out the IPv6 stuff, right? And my subnet wasn't behaving in the way it quite should have been. So I took a little rounds, and I looked a little more, and I looked a little more, and I looked a little more, and it all seemed good. So what was going on? Maybe there was something foundational I was missing about networking that I'd forgotten in the long ago of my career. Been at this for a while now. I'm really tired, okay? And that's when I discovered this thing. And when I found it, it was a real kicker, right? Be honest, I've been working on this thing for 3 months at this point, right? This is like March of this year. And half the time I was working on the product, half the time I was dealing with this, right? And this issue just sapped all of the fun and the joy out of building on AWS for me. AWS services don't support IPv6. It's not true, quite true. 87% of AWS services don't support IPv6. 5% do, and 7% support a dual stack. So why is that an issue? The long and short of it is, if you want to access an IPv4 enabled service on the internet, you need to have an IPv4 address assigned to the thing that's communicating with it. Your computer's got one, my EC2 instance doesn't have one. It can't communicate with anything inside of AWS. So thank you, Cloudflare, got on the internet. Amazon, what on earth? Right? So even though I could reach them from the internet, the Amazon EC2 instance themselves couldn't reach anything inside of AWS. There's a table about this. Right? This is such a problem that companies have put together a grid. You can put in the regions and see how stuffed you actually are. Right? It's bad. So this is game over. Right? This is one of the key features of cloud computing. And it's one of AWS's central promises. You can go global in minutes. Right? It's everywhere. How? I can't even talk to an AWS service in the same region, let alone across the planet. It's astonishing. So you may have noticed at the top of this presentation, I told you my name, but not what I do or who I am. And that's deliberate, right? Because I'm not here as Sean Tracey, Head of Developer Relations at Expanso, nor am I here as Sean Tracey, former Senior Developer Advocate for the UK and Ireland at AWS. I'm not even here as Sean, a developer. I'm here as Sean, an AWS customer. And there's one thing that Amazon wants you to know. 5 minutes, brilliant. Plenty of time for vitriol. There's one thing that Amazon wants you to know about AWS, is that they're obsessed with me. All right? With us, with all of those who would choose to build on AWS. Right? But I ask you this, is this customer obsession at work? Right? The audacity of charging me for a resource under the guise of scarcity and then not updating their own services to support the new thing they say will solve my problems is just outrageous. But I have a solution, because everyone has a solution. And it's something that we can all do and we can all thrive with. And you can do it today. I binned AWS. I moved everything to Hetzner, because even though Hetzner does not have much in the way of IAC or orchestration or all the shiny things that make AWS deployments really easy and simple, one thing it's really good at is putting servers on the internet. Okay, and the crazy thing is, I can get 4 times the compute capacity for the same price of the cheap one on AWS, right? And the IPv4 address is included in that, all right? So, yeah, even though Hetzner doesn't have all the shiny things that AWS has, it doesn't cause me pain. Amazon has caused me pain. You would think that AWS, knowing that they're running out of IPv4 addresses, wanting to move people over to IPv6, that they would make this transition as painless as possible, that the docs and the CDK would be ready to go, that the services would support IPv6. Because this isn't a charge anymore to encourage good behavior, it's a tax. Right? And it's one that you can't avoid paying if you build on AWS. And before anyone says it, Sean, AWS has a free tier, and that free tier includes IPv4 addresses. That's great if you have a new account. I've been doing this for nearly a decade now. There is so much in that account that I can't migrate or move without spending weeks of my life working on, right? But, There are so many better ways that Amazon could handle this, but this is not my monkeys, this is not my circus, right? But Amazon isn't obsessed with me anymore, because I'm no longer an AWS customer. If they were really obsessed with the customers, this just wouldn't have happened. That's it. That's the talk. If I'm missing something foundational, if I have missed something foundational, I am begging you to come and talk to me. All right? This has been 3 months of my life, all right? And I do not want to do it. I'm not angry. I'm not angry. I'm not angry. Right? I'm just disappointed. Okay? Two slides back. That one. I wasn't sure that was going to land, but I'm quite pleased I put that together now. Poor Andy. So yeah, I've been Sean. Have a good one. Any questions?
Has the AWS stopped being customer obsessed because they changed the CEO?
As a former Amazonian, yeah, I think that is the case. Like, Amazon extols day one ideology. It's day two. We're in day two at this point. You know, things don't work the way they should be. Things are priced weirdly. You know, like, they want you to think that there's no other cloud out there, but actually there's a ton of them, and they're really good. They're not as good in lots of ways, but if you're looking for like foundational cloud infrastructure,
okay, good stuff.
you know, I found 3. I just chose the cheap one. Give it a Google. But yeah, I don't know what's going on over there. I don't talk to people at Amazon very much anymore, and it kind of breaks my heart because they're all really exceptional, bright people. But this sucks. This is really bad, you know. So yeah, cough up or suffer. You know? Yeah. Any other questions? Question.
Don't want to can I share experience?
Sorry?
Can I share an experience?
Please do. Yes, we have an experience.
I had to start the blockchain node.
Oh, of course. Here we go. Enjoy.
Very similar for the journey. I had to start the blockchain node.
Mm-hmm.
First choice was GCP in the US because other nodes are running there, so I'm the closest, the lowest latency.
Yep. Perfect.
I couldn't start a server with 2 terabytes hard drive.
Why?
Because I would need to make a request to get approved for it.
Mm-hmm.
Yes, so then I went to AWS.
Mm-hmm.
And it allowed me to launch an instance, but they said they would need up to 4 hours to approve it. So I was waiting in the middle of the night for 4 hours.
Nice.
Nothing happened.
Go global in minutes, Fox.
I clicked launch instance. It never appeared. No email. Nothing. In the morning, head snare, and it's running. And the UI looked so horrible. It was so scary. But because the UI is a disaster.
Oh yeah, it's bad. It's very red. Yeah.
So sorry, I'll be banned from this group. And
Not at all. Not at all. This is an open forum. I don't run this shop, but I'm making an open forum. So, any others? One there.
One there.
In all your pain, did you find anywhere like any indication of like the rate of IPv6 being available on the services, like the trajectory?
Yeah, it's this. It's plateaus. Like that needle hasn't moved in 3 months, and the charge came in 5 months ago. You know, I don't know why this isn't priority number 1. You know, stop building new things, make the old things work with the new thing. You know, that's 30 years old. It's older than Amazon. You know, so yeah, no, this is why I'm disappointed, not angry, Yeah. Question, and I think that should be the last one. Yeah.
Do you think on some level though they do just don't care about you?
Yes.
You being one person who wants to do something that probably isn't going to generate Amazon or AWS much profit.
Yep.
And for large companies that are burning tons of cash,
Yep.
small IPv4 charges aren't huge. So what's the point in them fixing it?
They're not huge in isolation, but those big companies with tons of developers and tons of instances, they are big, because there'll be thousands of them per month every year. So if you're making millions of dollars revenue and there's a 6-figure sum coming out just for the IPv4 allocation, you're going to question, is that a necessary charge? And so Amazon doesn't care about me. I am just a lone developer, right? But I'm no different from a developer in those big companies that don't want to deal with this either. And you know, as these things migrate and more IPv6 is supported, and it is an inevitability that we're going to have to use this, if that's not fixed, that's going to be a problem. And other vendors are going to start being a possibility, an option. Other vendors will start eating Amazon's lunch. They've already started in some ways. So they're going to have to learn to remember to be obsessed with the developer again. Because me out on the outside and them on the inside, it's no difference. No difference, it's just time and scale. That's one man's humble opinion. There we go. Thank you, Chris.
Thank you very much. Cheers,
It's
Sean.
a pleasure.
Can we have a round of applause for both our speakers? I feel like